Hello everyone, welcome to solve this nice math Olympiad algebra problem, and here we have x square equals to 2x and we solve this problem for the values of x. So here the very first step we are going to do is here first we need to take the natural log on both of the sides, so that when we take natural log on both of the sides it is written as log of x square equals to log of 2 to the power of x. And now in the next step here we need the nice property of log, and we move this exponent 2 in the front of this log, and it is written as 2 times of log x. And in the right hand side we move this x in the front of this log, and it is written as x times of log 2. And now in the next step here we need to divide both of the sides by 2x in order to move the terms involving x in the left hand side and the constant terms to the right hand side, so that we divide both of the sides by 2x. So here when you divide left hand side by 2x, it is written as 2 log x over 2x. Similarly in the right hand side when we divide both sides by 2x, it is written as x log 2 over 2x. So now here you see that these 2 and 2 are cancelled by each other. Here this x and x are cancelled by each other, and the remaining terms are log x over x in the left hand side and log 2 divided by log 2 in the right hand side. So these are the remaining terms. So now here I can just introduce the Lambert W function. So you can already know about Lambert W function. It is stated as w of e to the power of a, it is equals to a. So this Lambert W function is simply tells us that if you have an exponential function with base e, so its exponent is multiplied by here, then the output of this type of function is the exponent of e. Okay, so now here first we make this type of condition in the left hand side of the above equation, and then we apply the Lambert W function. So here the condition is that here we make first the exponential function with base e, and its exponent is multiplied by here. Okay, so now we need some working to convert this log x over x in this form. So that here you very well know about, if you have a term x and then we apply the log and anti-log at the same time on x, it is written as e to the power of log x. So e and log are cancelled by each other, so you again get the term x. Okay, so after that here we just replace this x by e to the power of log x. So this equation is written as in this form here. We have log x divided by e to the power of log x equals to log 2 divided by 2. Okay, so now after that here we move our denominator to the upsides, and it is written as log x into, when we move this term upside so that its exponents becomes negative, and it will be written as e to the power of minus log x equals to log 2 divided by 2. And after that here we make the exponent e here, but we made the exponential function with base e here, but its exponent is minus log x. So here we have only log x, we need a negative sign here, so that now we multiply both of the sides by minus 1. So we write it here, multiplying both of the sides by minus 1. So when you multiply both of the sides of above equation by minus 1, it is written as minus log of x into e to the power of minus log x equals to minus log 2 divided by 2. So after that you see here we have we made the condition of Lambert W function, so that now we ready to apply this Lambert W function on both of the sides. So that here we just take this W function on both of the sides, and it is written as W of minus log x into e to the power of minus log x equals to W of minus log 2 divided by 2. So now in the next step here we need more simplifications, and first we apply the definition of Lambert W function in the left hand side, so that the output of this function is written as in this form. Here we just move, we have the exponent of this exponential function e, so it is minus log x, and in the right hand side we have w of minus log of 2 divided by 2. So because in this question our target is to find the value of x, so that now we move this exponent minus 1 to the power of this x by using the nice property of logarithm. You know that if we have n times of log a, it is equals to log of a to the power of n. We use this nice property of log to the above term in the left hand side. So now this minus 1 moves the exponent of x, and it is written as log of x inverse is equals to w of minus log of 2 divided by 2. Okay, so now here our next step is to eliminate this log here in the right hand side. So you know that in order to remove this log here, we need to take the anti-log on both of the sides. So here we take this e on both of the sides, and it is written as e to the power of log x inverse equals to e to the power of w of minus log 2 divided by 2. So in the next step here we need some simplification. You know that this e and log are gone by each other, and in the left hand side we get only x inverse equals to here we have e to the power of w of minus log 2 divided by 2. So here you see that the exponent of this x is negative. So in order to make this positive, first we write it here 1 over x equals to this term as it is, and then now in the next step we move this term in the right hand side, because this is multiplied by here. When we move in the left hand side it is divided by 1, and we write it as 1 over e to the power of w of minus log 2 divided by 2 is equals to x. So here when we move this exponential function e to the upsides, it is written as x is equals to e to the power of minus w into minus log 2 divided by 2. So this is our final answer in this question, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.